Example 5.1, because before we go through this example, just back to this moment of inertia from this moment of inertia from different shape of the area. You can remind you from the static that, for example, for the rectangle, okay, moment of inertia is 1 over 12 b is power 3, and for the y-axis, so we can use this equation to estimate the moment of inertia for the rectangle, and for the circle is equal for x xc and yc pi power 4 divided by power 4 divided by 4. For this, for the semicircle and triangle, and for the quarter circle. Okay, we're going to use this later. In the next example, for the 4-meter diameter circle gate, okay, that is the circle gate is located in the inclined wall of the last reservoir containing water, is gamma water. The gate is mounted on the shaft along its the horizontal diameter. Okay, and for water depth is 10 meters above the shaft. Okay, determine the magnitude and location of the resultant force exerted on the gauge by the water, and B, the moment that would have to be applied to the shaft to open the gate. Okay, so keep what this is. Being information that is circle gate diameter is 4 meter. Okay, and this gamma water is the 9.8 kilonewton, and in this case we assume that the HC, the centroid of this area, is 10 meter. Okay, and find what we want to know. We want to find what is the resultant force and what is the location, and B, at the moment to open the gate. So in this case we can classify that it is a submerged inclined plane. Okay, submerged inclined plane. Okay, so next we draw the figure diagram. Okay, that is draw the axis, y-axis, x and y-axis. Okay, that is the shape of this the centroid, and this is center of the pressure, where the resultant force acting on the center of pressure. And this show the fluid diagram of the gauge. There is the FR and reaction OX and OY, and the weight of the gauge and the moment. Okay, so next step we can find the first resultant force. Okay, equal to gamma SC, the depth of centroid times area. So we know the gamma, we know the depth of the HC, the centroid depth, is equal to 10 meters, is already given, and the area is pi over 4 d square. So we can estimate that the resultant force is about 1,232 and 761, about 1,232,000 Newton. Okay. Next step we want to know the location of FR. Acting on the plane. So based on what we learned from the lecture, that XR is equal to IXYC YCA plus XC, and for YR is equal to IXC divided by CA plus YC. That we from the we realize the location of the resultant force based on equation of the moment of inertia. In this case, we prove the symmetry. Symmetry because it's circle gate, so it's symmetry along the y-axis. In this case, it means xr is 0, or xc is 0, and ixyc is 0. So it means yr is on the y-axis. Okay, so that is yr. So this is yr here. Yr is along the y-axis. Okay. That along a. That a. So this is okay. That a to a, from a to a. Okay. And next we find what is the yr. So yr is the moment of shear. So xy for the circle ixc, so we can look back to this for the circle. You can use this equal to pi r power 4 divided by 4. Okay. Equal to pi divided by c. Yc is equal to 10 divided by sine 60. Because in this one is this is yc. Okay. So yc is equal to 10 divided by sine. This one is 60. So yc equal to 10 divided by sine 60. Okay, and divided by area is pi r square. And plus yc is the 10 sine 60. So this is equal to 0.0. Substitute number, got number 11.547. It's about 11.64 meter. Okay, so that is we can find that this location is this is a yc, and this is a 0.066 meter. Okay, show the length that y side is longer than yc, because yc is about 11.5 meter. And then next we take the moment allowed point c to 0. Look at the Fibonacci diagram moments plus y. Substitute the resultant force. And y1. So this is y1. Okay. Take measure of centroid. Okay, the moment is about 10,000, 106,000 Newton meter. Okay, why did this problem? We can solve this problem use method of prism, but this is show how to use method of prism to solve this equation. This is the problem. Okay, we can use the method because we divide the vertical force into two force like this. It means this is for the vertical force W1, W2, and we can find the F1, F2. Okay, but for this, if we want to find W1, we have to use to find the volume of water above equal to rho g. Okay, as equal to A1 H1 rho g. The problem is if we look at this for the area A1, A1 is the oval shape. Or we call it ellipse shape. So that is difficult to find the shape of A1 and to find the U1 as well as the A2. Also the ellipse shapes or oval shapes again. So for the inclined surface, it's difficult to use the method of prism to solve the problem because of this reason.